Welcome back to physics, and today we are going to do a practice horizontal projectile motion question.
It's actually murder.
So, we have a practice problem, and I started our chart. Okay, this is the way, as soon as you recognize something is a horizontal projectile motion problem, you should be comfortable enough to fill in some of this given information. Okay, so remembering for a horizontal projectile, we have an initial velocity of 0 in the y or vertical direction. We have our acceleration of 9.81 in that direction. Our times is the only thing that can go across. No acceleration in the x, which means our vi and our vf are the same.
Okay, just before we go on, you should be copying this. And again, like Ms. Becker said, you should be able to fill in these pieces of information every single time for a horizontal projectile motion problem. The question is, how are you going to tell whether or not this question that you're working on is a horizontal projectile motion question? Now, it's very easy to decide for this particular video because this whole video is about horizontal projectile motion. But what if you were at a quiz or a test? What would you do? How do you find out whether or not it is horizontal projectile motion? Well, if you read through the problem, every single one of these horizontal projectile motion problems all look the same. You have some object being thrown or fired or driven or whatever it is, but off some kind of height with some initial x velocity. Do they have to give you the x velocity? No. They could give it to you in reverse and tell you the car or the body or the person or whatever it is landed some distance away from the height that it drove or flew or was thrown from. They all look the same. The best way to do it? Draw a picture. Draw a picture of what's happening and you should be able to see that it's horizontal projectile motion.
Alright, so I'm going to let Mr. Petersack read this story about himself. And as he is reading it, when I hear a given piece of information, I'm going to add it into my chart. Okay, you should be trying to do the same thing and seeing if your chart ends up looking just like mine.
So I will read the story about my death. Myself is driving a rental car at 20 meters per second as I approach a cliff. I try to hit the brakes, but nothing happens. Probably because somebody cut the brake line.
It was a rental car, so I don't know what happened to it.
If the cliff is 80 meters high, how far from the base of the cliff does my body land?
So you should have been able, as he was reading through that question, to identify that that 20 meters per second is the initial velocity in the x direction. But we also said that our initial velocity and our final velocities are equal in that x horizontal direction, so I can fill it in for both.
Let's talk about why. They are the same because there is no acceleration in that direction, which means the velocity will not change. But the reason why is because there is no force in the x direction to speed the car up or slow the car down. Yes, of course, there is air resistance, and this is a big car moving at a fairly large speed. It would, in real life, have some air resistance. But for our class, we ignore that. So, there is no acceleration in the x direction. That means that the x velocity does not change.
The other piece of information that we should have been able to pull from this is that we're saying the cliff is 80 meters high. As soon as it says 80 meters high, you should recognize that's talking about a vertical distance. So that's going in our y column as 80 meters. And the next thing, now that we have all of our givens written out, we need to identify what our unknown is. So it's saying how far from the base of the cliff does his body land? Okay,
so right there, the final answer for this question would be a distance in the y direction, which means the units for the final answer would have to be the units of distance, which is meters. There are still some people out there in physics land that are having a problem deciding what is the final answer supposed to be and what are the units of that final answer. So because the question says how far is a distance, your answer should have meters for a unit. Don't give me a time for your final answer because you're technically not done. Distance in the x direction.
So when I look at my x direction, if I'm trying to find my distance, I start looking here and I don't really have enough information. So a lot of the time, what's going to help us is the one thing that can go back and forth between the two sides of our chart, which is time. So we're going to want to solve for time first, because that's going to give us that added piece of information that we can also use in our x side. We have more information over here in y, so I'm going to solve for my time using my y information.
Okay, here's a trick. Unless they gave you the time in the problem, you pretty much always have to solve for the time. Then the question is, how do you solve for the time? Think about it this way. If we only had an object moving in the x direction, not the y, one-dimensional motion, if this object is moving in the x direction, there is nothing in its path, as far as our picture is concerned, to stop it in the x direction. It's not like I drove into a wall, which means I would have a distance in the x direction to cover in some amount of time. We're just driving this way, and there's nothing in that direction to stop me. So what does stop me? The ground. The ground is technically in the y direction because it's down. So what do you need to use to find the time? Y information. Please do not get your y information and x information confused. They are independent of each other. Do not put y information into x equations, and do not put x information into y equations.
So what I like to do before I write out my equation is just identify what I am working with. So I'm working with my y information, so I'm going to write that out just to continually remind me that I'm working with y information. And he's actually giving me some more room, so I'm going to move it up there. So I'm going to identify, I'm talking about y information, so I can only use y information. I have a vi, I have my a, I have my d, and I'm looking for my time, we said. So you should be able to go to your reference table, or possibly use your memory at this point, that we should be using d equals vit plus 1/2 at squared.
Hold on. Why can we use that? We can use that because it does have an acceleration in the y direction. Remember, you can use any of your UAM equations for y information, but you cannot use any UAM equation in the x direction. Why? Because the acceleration is 0.
So we'll talk about what equation we can use there in a minute. But as I go through to solve this, my VI is 0. So just like we've done in previous problems, that goes away and becomes 0. So when I go to plug in, I'm plugging in a D, and I'm talking about my y information. So my distance in the y is 80. 1/2 times my acceleration, again my y information, my acceleration in y is 9.81 meters per second squared, times t squared. You should be comfortable enough at this point that I don't need to write out all of the intermediate steps to do that math. If not, you should be coming to extra help to go through all the math. But you do get a time of 4 seconds. So I can put that in my y column, and I can also put that in my x column. Remember, that's the one piece that can go back and forth.
The reason why is when time stops, it stops in the y direction and the x direction at the same time. There is no way this car could, or myself, could land in the x direction or y direction and stop in the x direction at different times. It happens at the same time. So now we get to our x equation stuff. Because we don't actually ever need to know my final velocity in the y direction. We could find it if you wanted to, but we don't need it. So we're just going to skip it. Finally now, x side. Well, you can only use one equation in the x direction. And that's because it's constant velocity, or it's an average velocity. So the only equation you can use in x direction ever is v is equal to d over t. So, since we already have a time, we already have an x velocity, just solve for the distance. So distance would be velocity times time, which is 20 meters per second, times 4 seconds, which gives you 80 meters. Which is weird because that's the same height that we fell from. But we did not plan that, that just happened. Alright.
So that's how far he would land from the base of the cliff, and then you would write that out as your answer. As you're going through these questions, there's a couple of key important things that we should probably review. The first is to make sure you're good with writing out this chart. Writing out this chart counts as writing your givens and your unknowns. Okay? Start here. Please, please, please do not take shortcuts. I know we like shortcuts. They don't always work. Okay? Write out all of the givens, write out all of your work. As you start solving for things, make sure you're double checking, what was the question asking me? When you get here and you say, okay, times 4 seconds, whew, I solved something, I'm good, double check it. The question was originally asking how far. We should recognize that's not a time, so we need to kind of finish following through and get that distance of 80 meters.
Finally, your equations and your givens have to match up. You have any UAM equation to use in the y, but only constant velocity in the x. So, if you're trying to use a UAM equation to solve for the x distance or the x velocity, if you don't have it, it's not going to work. If you try to use constant velocity in the y direction, it's not going to work. Please make sure you understand that x and y are independent of each other, and they have their own equations.
Okay, so we will be having a quiz on horizontal projectile motion on Friday, so make sure that you're getting comfortable with this, you're good with all of that, you're separating out your y and your x. Do some more practice problems. You all have this packet at this point. The first half of it is all horizontal projectile problems. Work through them, come in and see us if you have any questions on any of them.
If this makes sense to you, you're doing good right now. But please understand, it gets harder.
I think that's it.
Have a great night.